Hello guys, this video is in continuation of your earlier class. The last class we were discussing about Scott connection, so we shall continue that. So Scott connection is used to convert what? From 3-phase to 2-phase. So it is used for industrial furnaces wherever the phase angle required 90 degree, there we are going to use such Scott connection. And also with a special arrangement in the secondary side, you can also use the 2-phase for 3-phase loads also, like I discussed in the last class. So here, V2T, I2T lie on the same phasor, whereas V2M, I2M lie on the same phasor. The reason why, because we are assuming load is unity power factor load. That's why the reason I2T, V2M, I2T, V2T as well as I2M, V2M are lying on the same phasor. And coming to this triangle part, and we came to know that virtual neutral is present somewhere here, and also we came to know that Rn is in the form of 2 and NO is form of 1, that is 2:1 ratio form. We proved that, yes or not? And again O is dividing the main transformer at the center, so each has the voltage V1 by 2, V1 by 2, that is anyhow VL is applied, VL by 2, VL by 2. That is why the reason you can see between B and Y the voltage is being divided at the point O, that is VL by 2, VL by 2. And this is N is the neutral part, perpendicular line here somewhere. It is the value, the distance is in form of what? 2:1. This is from Rn it is 2 and from NO it is 1. So it is 2:1 form. And whole RO is how much? It is √3 by 2 times of N1, like I told. Yes or not? Fine. So if you want means you can hope you understood this. That is YB is nothing but what? It is divided at the point O. So that's why the voltage BY is divided into two parts, that is VL by 2 as well as VL by 2. And anyhow we know that this is a neutral point N, and Rn is in the form of 2 and NO is form of 1. So it is divided by the ratio 2:1. Okay. So now coming to this RB as well as RY, how this VL has come into picture? Very simple, just apply Pythagoras theorem over there. That is BR square is equal to OB square plus RO square or OR square. So let us say that we don't know any BR value since it is a question mark as of now. So OB square equal to what? VL by 2 whole square. And what about RO? RO is √3 by 2 VL. Yes or not? So it is √3 by 2 VL whole square. Yes or not? So VL, if you take outside common, means inside will get what? 1 by 4 plus 3 by 4. So if you add those two, means 1 plus 3, 4 divided by 4, again it reduces to 1. So the length of BR is what? VL. So that's why the name length of VL is length of BR is VL. Similarly, length of RY is VL. Anyhow, it is a same. Yes or not? So this is how VL has come here. Now going to the explanation. Next explanation. We know that your transformer primary winding, that is of main transformer, carries it consists of two parts because it carries I1M there. So it does two work there. So first work is what? It balances the main secondary current I2M. Here I told, right? It balances the main secondary current I2M. This is M actually. This should be M, I2M. Okay. So the first half, this is the first half which balances I2M, and second half balances the half of the teaser current. Second half of the main transformer of your primary winding balances the half of the teaser current, that is primary teaser current, that is I1T by 2. Second half balances I1T by 2 and first half balances secondary current of your main transformer I2M. Okay, these are two things which your main transformer primary winding do. Okay, so now what you can write here is, if I want to know the values of what current IR, IY, IB, then easily I can write IR is equal to I1T, because IR and I1T are they are traveling in the same direction. So IR vectorically will become equal to I1T. Yes or not? Till here to till here, what it is? It is IR, right? Yes or not? Here then it is going to divide I1T by 2 and again I1T by 2. Yes or not? Here at the junction point O it is going to divide, but till here from R to O it is IR itself. Yes or not? So IR is equal to I1T. Now coming to this Y2O, that is IY. Let us say I need to find out the value of IY. Is it IY is equal to I1M? No, right? Why? Because I12 is getting added up here like this. Yes or not? I12, the I1T by 2, it is flowing somewhat like this from top to left side like this, as well as I1T by 2 flowing from top to right side like this. So will my IY becomes equal to I1M? No. It will be what? IY is equal to I1M minus I1T by 2. Yes or not? Because it is opposing, right? So we believe the fact I1M is greater than the teaser current, that is I1T by 2. That's why what we do is IY is equal to, because IY is in the same direction of I1M, like your ECA, your KCL law says. So IY is equal to I1M minus I1T by 2. What about IB then? What about IB? IB can see that anyhow, let us assume that I1M direction like this. For sake of convenience, we shall ignore this I1M. Only we shall consider I1M is flowing in the clockwise fashion. Okay. So now IB is flowing like this, and I1M is flowing like this, as well as I1T by 2 is also flowing like this. So totally I1T by 2 as well as I1M is opposing, both are opposing IB current. So that's why IB is equal to minus I1M minus I1T by 2, because since both are opposing, so that's why it is minus sign there. IB is equal to minus I1M minus I1T by 2. Okay, this is what they have written here at the bottom. Okay, IY is equal to what? I1M minus I1T by 2, like I told you. Yes or not? And IB is equal to what? Minus I1M minus I1T by 2. It's the addition of both the currents. Since it's opposing, so minus sign you can write on the both sides. Yes or not? IB direction as well as I1M, I1T by direction are both opposite vectorically. So we are writing what? Minus direction. Okay. So this triangle we already discussed there. Yes or not? So finally what I can write here is IR is equal to I1T, like I told, and IY is equal to IB is equal to, if I write in terms of magnitude, you can take all the minus sign goes, because if I am taking magnitude means, so it will be square root of mod. You apply mod for this as well as you apply for mod for this also as well. So IR is equal to I1T and IY is equal to IB is equal to square root of I1M whole square plus half I1T whole square, if you want to calculate only magnitudes of the current. So one thing what I came to know here is, in terms of magnitude I1 and IB will be same, but maybe they may differ in terms of direction. Okay, so in magnitude the value of I1 and IB will be always same. Okay, fine. Now coming to this triangle, this already we know that V2T, I2T, I told that we are connected a unity power factor load. So V2T, I2T will lie on the same phasor. Similarly, V2M, I2M will lie on the same phasor. Yes, and say, let us say Rn value, Rn length is IR and Yn length is IY, and as well as Bn length is IB. So R, Y, B, IR, IY, IB. Okay. So since we know that IR is equal to what? I1T, right? Already we discussed IR is equal to I1T. So that's why Rn length is nothing but I1T. And also we know that I1T is equal to 1.15 times of K I2T, because already we have proved this. Yes or not? Here 1.15 times of K times of I2T, I1T value. So that's why I replace this. Hope you understand this, right? So this is nothing but what? I1T is nothing but equal to IR. IR is equal to 1.15 times of K times of I2T. And coming to this IY, we know that IY is equal to what? It is summation of I1M minus half I1T. Yes or not? It is minus I1T by 2. That you can remember like this. So this is IY. So this is the resultant of two vectors here. This vector is minus I1T by 2 and this vector is I1M. So I1M minus I1T by 2 will result to IY. Anyhow, this length is also same and this length is also same. You can write I1M here also. You can write I1M here also. Okay, here also same, minus I1M. So make sure to write here O here. They have missed here. So BO length is also I1M. Sorry, minus I1M. And again, this length is also minus I1M. Okay. So IB length is equal to minus I1T by 2 minus I1M. Okay, this is minus I1M or this is minus I1M. So this is the resultant IB. Okay, similar to that itself. but if you want to calculate the magnitudes only, then you have to apply mod on both sides. This will be the answer. So here one thing we came to know that since the teaser transformer current travels in the main transformer into two equal halves, yes or not? It was used to travel here, already I discussed. Teaser transformer current is going to travel in the main transformer, the two equal halves, one at the right side, one at the left side. So what happens there is, so due to the flow of the current in opposite direction, there will be no any effect in the magnet. That is, there is no any magnetic effect on the core. So it does not take part in any of the balancing of the secondary current, as one cancel out the other, so it does not contribute towards the balancing of the load, you can say, you can call. Okay, so that's why when two phase load of unity power factor is balanced, then three phase is also balanced. This is what the verdict of this Scott connection. So now let us assume that we are going to connect the load where it is lagging by power factor 5. As you can see, before I2T, V2T was lying on the same line, and I2M, V2M were lying on the same line. But here, what has happened? We are going to connect a certain lagging power factor, so that I2T lags V2T by 5, as well as I2M lags V2M by certain angle 5. Since both power factors are same here, we are assuming two different same lagging power factor loads connected on the secondary side of the main as well as teaser transformer. In that case, this vector will tilt or shift like this, as we know that I1T will no more will lie on this, yes or not, as we know that it has certain phase difference of phi, so that's why this is, you can consider it as V2T and everything. Okay, so it has a phase difference of phi, so whole phasor will get shifted by an angle phi. Okay, and the rest of remain will same. Iy is equal to minus I1T, I1M, as well as Ib is equal to minus I1T by 2 or minus I1M. Okay, everything remains same. That just you have to shift the whole, tilt the whole phasor diagram by angle phi. Okay, any of you know that I2T and I2M is equal to what? I2, already we discussed this, yes or not? Yes or not? I2T as well as I2M is equal to I2. We shall assume that both the loads are assuming the equal, that drawing the equal currents at a power factor load cos phi. So that is why the reason everything is shown in the form of balanced. So I2T, I2M are of the same magnitudes. Okay, just we are believing that loads applied are balanced. Okay, so the same thing again you can write here from the phasor diagram. Even with this phasor diagram also the formula remains same. IR is equal to I1T and Iy is equal to Iy is equal to square root of I1M square plus half I1T whole square. This you already know. And also we know that I1M is equal to k times of I2M. This also we have proved this. Yes or not, since I2M is equal to I2, so they have replaced I2M by I2 over here. And similarly I1T is equal to what? 1.16 times of k times of I2T. This also we have proved. And any of I2T is equal to I2. So again I am going to write it as I2 here, replacing I2T by I2 and substituting IR is equal to what? 1.16 times of K I2, because I1T already we have written, so IR is equal to I1T is equal to this. And now substituting back here, we know that I1M is equal to what? K times of I2, and again I1T is equal to, already we have discussed here, 1.16 times of K I2. I will replace that and doing the calculation, finally IY and IV is equal to what? 1.16 times that of K I2. Okay, this is what we get if we consider the load is balanced, having a power factor angle at angle phi. Okay, so therefore all the currents in the primary side are equal in magnitude. Okay, that's what Iy and Ybl was same, and IR is 1.16 K times of I2, whereas Iy and Ib are both same. So that's why the reason all the currents in the primary side are equal in the magnitude. If you want to calculate tan theta and all, then tan theta is nothing but what? Opposite by adjacent. So this is theta, if you are considering angle here. So this will be opposite and this will be adjacent. It will be what? Half I1T by I1M, yes or not? Half I1T by I1M, neglecting the negative signs and all. And again I1T, I already know that it is 1.16 times of KI2. So substitute there and you get cancel out. So tan theta is equal to 0.58. and if you do inverse, then theta is equal to 30 degree. That is theta is equal to tan inverse of 0.58 and theta is equal to 30 degree. Okay.